welcome. So today I'm going to be sharing with you one of my latest tutorials. We're going to be walking through how to help ladies identify human hair wigs, differentiate between human hair wigs and synthetic wigs using machine learning. So this problem stemmed out from the fact that I think sometime in 2018 or early 2019, my wife and I, well, my wife mainly started a hair business, and lots of complaints we got where we don't know if it's original, we don't know if it's synthetic or human hair, yada yada yada. And people were only able to differentiate at the only when we bought, and people used it and they complained. So here we're going to use machine learning, computer vision, to be able to differentiate before buying at all, so that you can buy quality. Basically, I'm going to be scraping images from a website, doing some interesting things, and then we'll be using Amazon SageMaker for the model training and model prediction. So here I'm going to show you. These are just functions that are scraping the website. The website I'm scraping is glamoroushair.com. So they have images of hairs. They sell hair, so I'm using images from there. Yeah, so here's, if you go here, you see synthetic here. You can also go here for human hair wigs, and you can see. So what I do with this scraping is that I go for each page, for both pages, human hair, synthetic hair, I go to the home page like this, then the function goes in and takes the images, because I need as many images as I can get for having a very good model. So here I'll just show you the function. So this crawls the main page, and then at some point it goes into the inner page inside the main page, which is here, and then it uploads the images to S3. Each image of each product is uploaded to S3, and this is where it uploads to S3. And here, so I do the crawling the main page for human hair. So I tell it that scrape human hair with the URL and the class for me to identify when I'm training the model on SageMaker, and also synthetic hair. Just for some business background, because I like to look at it from a business perspective as well. So the title is using artificial intelligence to differentiate between human and synthetic hair wigs with Amazon SageMaker. Basically, according to China Customs in 2018, the entire wig exports from China to countries across the world topped the excess of $2 billion. So that's a really huge industry. And yeah, with USA being the largest destination. That said, I spoke with a handful of ladies and my wife's business's customers, and we figured out that trust is a major issue, which is as the result of vendors not knowing and selling synthetic hair as human hair. So there's a mistake here, so just correct that. Selling synthetic hair as human hair. Yeah. So what we want to do is to figure out if we can use machine learning to quickly identify if a wig is synthetic or human hair, and ensure that even the vendors can ensure that they buy quality hair, and the end users or the end consumers as well, the ladies making the hair, can also buy quality hair. So for me, I usually start with an hypothesis. It's not necessarily like the statistics hypothesis, but an hypothesis for me to say, if my model is able to reach a certain accuracy in the validation with the validation set, I would accept it. So here I say, if my hypothesis, if we can differentiate between the synthetic and human hair wigs with images right before customers complete a purchase, then we can help customers build trust with hair vendors. We will know that we succeed if we achieve a 65% accuracy with our machine learning model. So 65% accuracy, I'm referring to the validation set. So like I said, the data set is from the Glamorous Remy website. All images were stored in S3, and the model training is done with Amazon SageMaker. So some pre-processing. I'm using the Amazon SageMaker built-in image classification algorithm, and it requires the images to be in a certain format, so the record IO or the LST format. So, and that's based on MXNet. So that's what I had to do here, to copy the Python script that converts my images to record IO format. And here, after converting the images, you can see here, human hair class is 0, synthetic hair class is 1. So for both train and validation set. Then Here I just list the LST file to see what's inside it. So here it says index, maybe the file number 69000. This is human hair, where it's located, and 1.0 synthetic hair, where it's located. Before that, just to show you something really quick, this is a Python library, because when I downloaded my images, it was all in one directory. So I can show you here. So you can see train human hair synthetic. It wasn't so here it's divided, but I had to use this split folders library Python. I think I already opened it here. So if you have multiple images and you want to distribute them or split them into training set and test set, and you want to distribute them evenly, you can use this library to quickly do that, so you don't have to do that manually. That's a quick one. So here I'm just specifying the location of the data in S3, and here I'm uploading using the Jupyter Bash kernel or command, or Python, the Jupyter Shell Magic, uploading to S3 quietly. This is where my images are located. Then here I'm doing this optionally to convert to record IO directly, but this is not needed, so this is just optional. So now I'm going to train my model. This is just specifying the training parameters, a training instance count, training instance type, and an output path where the model, the SageMaker model, will be saved in S3. Here I want to train my model using Amazon Spot instances, so manage spots from SageMaker. This will help me to save up to 70%, or if not more, between 70% and 90% of the training cost. So that already helps me to save a lot of money. Here I define my SageMaker estimator, and I specify the training image, which I took from here. The SageMaker get image URI, image classification algorithm. There's a built-in algorithms. You can find a lot of documentation. Let me see if I can open it. Built-in SageMaker algorithms. Yeah, so that, and there is also this URL. This workshop material is really good. You can find a lot of stuff here. I will add the links to the description in the video description. Here is also the documentation and a lot of things you can read about here. It's really good. So specifying the estimator, just a couple of things: training instance, use spot instances, and then here I specify the hyperparameters specific to the algorithm itself. So I will not be doing some major tweaking. I'm just going to specify some basics, like the number of training samples, so not total number of images that I'm going to use, just 191, so it's not so much. But if I want to build this making it production, I'll be looking at maybe between 1,000 and what's the thing called, maybe 1,000 and 100,000 images, depending on my use case. And here I'm using pre-trained model, so it's going to use transfer learning. So there's already some model under the pre-built model, and it's going to use transfer learning. To understand all these hyperparameters, I will not be going into the details. Here is documentation by SageMaker. You can find them here. The hyperparameters on the image classification algorithm, you can find them here. So it's really straightforward to get around and get started with. Yeah, so here I'm specifying my input data specification, just specifying where the training data is, the validation data, the LST file, so that it can pick it from, and then the data channels. So this is just serving as input into the classifier.fit, so the data it will train on. So here I do input, data channels, and I also want to see the logs in my Jupyter notebook as well. Bear in mind that this is SageMaker Studio. It just went general. It was just generally available like some 2 weeks ago, before it was in Northwest US East or so. But now I'm using. I think I'm working from EU West 1. So here it loads in the hyperparameters and a couple of other things like that, and I specified 10 epochs. So it's going to iterate over the training 10 times. And at every point in time, it outputs the accuracy. So for me, I'm really concerned about the 10th epoch and the validation accuracy at that point. So here it says, oh wow, it's really good. So I'd run this before, so I don't need to run it again. It's going to take a lot of time. So here it says 96% accurate on the validation set. Wow, that's really impressive. And let's see, 100% accurate on the training set. Well, that's fine. So 96% beats my expectation with the 65% hypothesis threshold that I set, so that's good. Then here it shows that I used SageMaker managed spot training, and it saved 70.4% of my training cost. So you can see that I'm only going to pay for so little, which is here. So yeah, so the hypothesis is validated. If I were to take this for a real life use case, I will be using hyperparameter tuning, training on lots of images, and I would also leverage the Amazon Augmented AI, which is the human in the loop service, to validate the training. So for more information, you can check this out. Amazon, it's new, Augmented AI, easily implement human review for machine learning predictions. That said, inference, I want to start making predictions with my trained model. To deploy a trained model, usually in the past we used to do write some Flask API and yada yada yada, upload the model, save it in something, some file, then da 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 da. But now SageMaker makes it relatively simple, not relatively, but way simpler. So it's just a one-line command. I just do image classifier, which is my trained model estimator. Dot deploy. I specify the initial instance count, which is 1, the instance type, and voila, I have my, after some minutes, it deploys the trained model, and I have my endpoint. So it's provisions for me an EC2 ECS container underneath the hood, and does some other things like that. Comes with monitoring. I can view logs in CloudWatch. I can view the metrics as well. I think we should even check out the metrics. Let me see this one. So let's go to SageMaker. It is really good, so we can already look at the metrics and see how that's performing. So if I go to endpoints, so while that's loading today, so you can see an endpoint image classification in service. Yeah, you can see the invocation metrics, how many times the model was invoked. You can see the instance metrics. You can also view the logs. You can see the memory utilization, disk utilization, and things like that, which makes it really cool. So I can actually monitor. It comes all with all these outside the box, so I don't have to think about how to instrument all this at all. You can see, so logs, and it does some pings to validate that the instance is running. So here it runs on MXNet. So like I said, so let's go back to what's interesting. So I'm going to use a couple of images. I already opened some of them. So like I took the training images, or the training images from Glamorous Air, but I'm going to be taking the images I'm going to be testing with from AliExpress. So just to say, to use the images that the model had not seen before. So the first image I'm going to be taking is this, which is here, I guess. This is synthetic air. I would specify the URLs as well. This is synthetic air, and this is the example picture. Where is it? Yeah, this is the example picture I'm using, which is this one, and I'm going to be feeding it into the model. Let's download it here, and then running the prediction. And it says human hair less than 0%, less than 1%, synthetic hair about 99.99%, so almost 100% sure it is synthetic hair. Wow, that's impressive. So let's try with another example, which is I think this one, which is straight human hair. So human hair, which is also straight, kind of looks like the previous one that we looked at. And the image I'm using is this. And then let's see if it works. So this is the image, and let's run a prediction for it. So it's almost 99% sure, 100% accurate as well that this is human hair. Wow, it's quite impressive. But let's try another example. So here I'm looking at this funny hairstyle. This is something like Afro hairstyle. Yeah, I think. Let me see where I found it. Can I still figure it out? Yep. Okay, I took it from one of the. I think I took it from one of the customer reviews. Just something that the customer was actually wearing. I took it from the customer reviews, and let's see what it does. So let's look at the image, and let's look at the prediction. So it's not sure. So it's not like it's 100% accurate, but it shows that this is either 54% human hair or 45% synthetic hair. However, it's synthetic hair. So it shows that the model is not perfect yet, but it's something that can be improved upon. So I believe that if this was to go into production, it was to go into production, adding more images and properly labeled images would help improve the model. So I hope you find this useful, and feel free to comment if you have any questions. Just let me know, and thank you.